Hello everyone, here we will be discussing the concept of convolution. Convolution is a mathematical operation on two functions that produces a third function expressing how the shape of the one particular function is modified by other function. Here we are going to discuss some of this convolution concept on Laplace transformations. Definition of the convolution we will discuss here. So let f of t and g of t are two functions. Convolution of f of t and g of t is denoted as f of t star g of t equal to integral 0 to t f of u into g of t minus u into du. So this is the statement of convolution. Here what will be there? Here how to get f of u? My example, f of t equal to cos t, g of t equal to e to the power of t I have. So how to convert it f of u? F of u becomes cos u. G of t minus u becomes e to the power of t minus u. That means wherever t comes I am replacing by u. Wherever t comes in g of t I am replacing by t minus u. So using this statement, using this particular statement, I am going to see that convolution theorem statement here. Convolution statement says that let f of t and g of t be the functions, then Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of f of t star g of t. So here we are finding Laplace transform f of t and Laplace transform of g of t and doing the normal multiplication. That will be same as once you find the convolution between the f of t and g of t and find the Laplace transform on that. So let us consider some problems on it. Let us solve some problems on the convolution theorem. The question will be verify the convolution theorem for the given function. So here let us consider the given functions are f of t equal to t, g of t equal to cos t. So now my first problem, I need to verify the convolution theorem for f of t equal to t, g of t equal to cos t. So here first write the what is the convolution theorem says here. So we know that convolution theorem says that Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of f of t star g of t. So let me consider the left hand side, L of f of t first. What is my L of f of t? Laplace transform of t. What is my Laplace transform of t? 1 divided by s square. You get that? Now Laplace transform of g of t. So that becomes Laplace transform of cos t. What is Laplace transform of cos t? Says that s divided by s square plus 1. So now what is my LHS says that Laplace transform f of t into Laplace transform of g of t. So this becomes Laplace transform of f of t into Laplace transform of g of t. So this is equal to 1 by s square into s divided by s square plus 1. This can be written as s divided by s square into s square plus 1. So 1s will get cancelled. I will be getting as I will be getting as 1 divided by s into s square plus 1. So let me give it as equation number 1. Let us take the RHS. Now let us take the RHS, Laplace transform of f of t star g of t. So let me find first f of t star g of t. That means convolution of f of t and g of t I am finding here. So g of t, f of t star g of t equal to, we know the integral 0 to t f of u into g of t minus u du. So this becomes f of t star g of t, that becomes is equal to integral 0 to t. What is my f of u? My f of t equal to t. My f of t equal to t. So my f of u equal to u. So I am replacing u in place of t. That's it. U. Is it clear? Now g of t minus u. My g of t is cos t. G of t minus u means wherever t comes, I should replace by t minus u. So that becomes cos t minus u. Cos t minus u into du. Now what we are going to do here? Now let me consider this. Now we use the Bernoulli's rule. What is the Bernoulli's rule? We have u v integral u v equal to, I can write it, u into v1. v1 is integration of v minus u dash into v2 plus u double dash into v3 minus dot dot dot. That means u dash means differentiation of u, v2 means integration of v1. So v1 is integration first time for v, and v2 is integration of second time. So now using the Bernoulli's theorem, I'll write it. Now I consider this as u. If I was to eliminate, if I consider u, so this becomes u as u into v1 integration of cos t minus u. This becomes sin t minus u. T minus u, since I have t minus u here, this becomes minus 1. So integration of this, it becomes minus 1. So minus u dash, differentiation of u, this becomes 1. I am differentiating with respect to u only, so u differentiation is 1. So into, now I need to integrate this, sin t minus u divided by minus 1 integration I should find. That becomes minus of cos t minus u divided by minus 1 into minus 1. So next term when I go for it, my differentiation of 1 will be 0. I don't need to go for next term. So this becomes 0 to t will be limits here. So this finally will become minus u into sin t minus u minus into minus plus in cos t minus u. Limits will be 0 to t. Now I need to apply the limits here. By substituting the limits, we will be getting equal to minus of u. I will be replacing as t sin t minus t plus cos t minus t. Upper limit is over minus, again lower limit I need to replace. One lower limit is 0. That becomes minus of 0. 0 into sin t minus 0. Next one, minus into plus becomes minus cos t minus 0. So we get minus t into sin 0 becomes 0 plus cos 0 becomes 1 minus 0, it will be 0 cos t. So finally 1 minus cos t will be my f of t star g of t. Now let me find the Laplace transform of f of t star g of t. So Laplace transform of convolution of f of t and g of t, f of t star g of t equal to Laplace transform of 1 minus cos t. So this becomes Laplace transform of 1 minus Laplace transform of cos t. So this becomes Laplace transform of constant 1 becomes 1 by s minus s divided by s square plus 1 equal to, and taking LCM I will be getting this s square plus 1 minus s square divided by s into s square plus 1. So this will be 1 divided by s into s square plus 1. So let me keep it as equation 2. Here is equal to Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of f of t star g of t. So by comparing equation 1 and equation 2, my LHS of my convolution theorem and LHS and RHS of convolution theorem will be same. So hence the theorem is verified. Okay, let us solve one more problem on convolution theorem. Verify the convolution theorem for given f of t and g of t. So write first convolution theorem what we have. Convolution theorem, I have a Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of f of t star g of t. So I am considering left hand side. So Laplace transform of f of t equal to Laplace transform of sin t, what I have here. This becomes 1 divided by s square plus 1 and Laplace transform of g of t. That means Laplace transform of e to the power of minus t. If Laplace transform of e to the power of a t, we know that 1 divided by s minus a. So that becomes here 1 divided by s plus 1. So here I multiply Laplace transform of f of t and Laplace transform of g of t. This becomes left hand side of my theorem becomes f of t, Laplace transform f of t into Laplace transform of g of t is equal to 1 by s square plus 1 into 1 by s plus 1. So I can write it this 1 divided by s square plus 1 into s plus 1. Keep it as equation number 1. Now I consider the right hand side and prove it same what I got to the equation 1. So now let me consider f of t star g of t is equal to integral 0 to t. What is the formula I have? F of u. What is my f? T here sin t. So f of u becomes sin u. Is it clear? G of t I have e to the power of minus t. What is my formula I have? F of t star g of t equal to integral 0 to t sin u into, that means f of u into g of t minus u. So in g of t I need to replace wherever t comes t minus u. It becomes e to the power of minus of t minus u into du. Now this becomes, this particular integral becomes integral 0 to t, integral 0 to t sin u into e to the power of minus t into e to the power of u. So we get e to the power of minus t into e to the power of minus u. I can write x to the power of a plus b equal to x to the power of a into x to the power of b form into du. Now look at it. Here e to the power of minus t is constant. I should consider this as a constant. Integral 0 to t e to the power of u into sin u into du. So this becomes, we have a standard formula. It's integral e to the power of ax into sin bx dx. So that case comes means we know that e to the power of minus t, the integration of e to the power of ax into sin bx dx, e to the power of ax divided by a square, a is 1 plus b square, b is also 1 into a is 1 sin u minus cos u. Is it clear? So now this becomes e to the power of minus t divided by 2 into e to the power of u into 1 sin u minus cos u. 0 to t. Limits will be 0 to t. So this particular case, now e to the power of minus t by 2 is outside. Now substitute the limit for the given. First I will take the upper limit, e to the power of t into sin t minus cos t minus lower limit e to the power of 0, that becomes e to the power of 0 into cos t. When I replace 0, sin 0 minus cos 0. Now simplify, e to the power of minus t divided by 2 into, we will be getting as e to the power of t into sin t minus cos t minus e power 0 is 1, sin 0 is 0, minus into minus plus cos 0 is 1 plus 1. So this will be the solution. So while multiplying, e to the power of minus t into e to the power of t becomes 0. E to the power of 0, e to the power of 0 divided by 2 becomes 1 by 2 into sin t minus cos t. Here again e to the power of minus t divided by 2 into plus 1 plus e to the power of minus t divided by 2. Now I need to find the Laplace transform of my f of t star g of t. So my f of t star g of t is this one what we got. So I am finding Laplace transform. 1 by 2 is constant if I take 1 by 2 outside. No issue. Laplace transform of sin t minus Laplace transform of cos t plus Laplace transform of e to the power of minus t. So this becomes 1 by 2 into Laplace transform of sin t becomes 1 by s square plus 1 minus Laplace transform of cos t becomes s divided by s square plus 1. Laplace transform of e to the power of minus t becomes plus 1 divided by s plus 1. Let us simplify this. On simplification, 1 by 2 into we will be getting 1 by s square plus 1 minus s divided by s square plus 1 plus 1 divided by s plus 1. What will be having here? So here by finding LCM here, so we will be getting 1 by 2 into s square plus 1 into s plus 1 will be my LCM. So I will be getting as s plus 1 minus s into s plus 1 plus s square plus 1. Is it clear? So this will be 1 by 2 into, look here, s plus 1 minus s square minus s into 1s plus s square plus 1 divided by s square plus 1 into s plus 1. Here minus s square plus s will get cancelled, plus s and minus s will get cancelled, 1 plus 1 will remain as a 2 for me. So this becomes 1 by 2 into 2 divided by s square plus 1 into s plus 1. So 2 will get cancelled. I will be getting 1 by s square plus 1 into s plus 1. So let me consider it as a equation 2. What is this? Laplace transform of f of t star g of t. So now this is my RHS in the convolution theorem. So I got 1 by s square plus 1 into s plus 1. Now 1 and 2 we get Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of f of t star g of t. So we got LHS equal to RHS, hence the theorem is verified. So let us consider one more problem on convolution theorem. Let us verify the convolution theorem for f of t equal to t and g of t equal to e to the power of t is given here. So first we know that convolution theorem, Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of convolution of f of t and g of t. So I am considering LHS here. So here Laplace transform of f of t is 1 by s square. Laplace transform of e to the power of t is 1 by s minus 1. So now Laplace transform of f of t into Laplace transform of g of t equal to 1 by s square into 1 by s minus 1. So this finally I can write it 1 by s square into s minus 1. So keep it as equation number 1. Now I need to find the right hand side Laplace transform of convolution of f of t and g of t, and should show that LHS equal to RHS. Now let us find Now let us find that f of t star g of t. So what is the formula we have here? Integral 0 to t f of u into g of t minus u into du. Now what is my f of u here? U. Wherever t comes, I should replace by u. Here t, wherever g of t, wherever t comes, I should replace by t minus u. So g of t minus u becomes e to the power of t minus u here. So this becomes integral 0 to t u into e to the power of t minus u into du. Integral 0 to t u into e to the power of t into e to the power of minus u into du. So my e to the power of t is constant, I take out e to the power of t integral 0 to t u into e to the power of minus u du. Now I use Bernoulli's rule. What is Bernoulli's rule we have here? Integral u v equal to u v1 minus u dash v2 plus so on so. So this becomes e to the power of t is constant, take out u, I consider as u, so u into integration of e to the power of minus u, that becomes e to the power of minus u divided by minus 1. Is it clear? So minus, now differentiation of u, that becomes 1 into e to the power of minus u divided by minus u, 1 e to the power of minus u divided by minus 1 integration is e to the power of minus u divided by 1. Minus 1 again becomes plus 1. So 0 to t will be limits. What happened here? If I go for next time, u double dash, this becomes 0. Next time will be 0 for me. So this becomes e to the power of t into minus u into e to the power of minus u minus e to the power of minus u, 0 to t. So now I will apply the limits 0 to t after applying the limits. So we got e to the power of t into minus u into e to the power of minus u minus e to the power of minus u. Limits varies to 0 to t. So now what we have here? Now let me take out minus outside. When I take minus outside, minus e to the power of t into u into e to the power of minus u plus e to the power of minus u. 0 to t will be my limits now. Now let me substitute my upper limit. E to the power of minus minus e to the power of t will be minus e to the power of t as it is common outside. Now I replace t into e to the power of minus t plus e to the power of minus t minus lower limit, right? 0 into e to the power of minus u minus into plus minus e to the power of minus 0. So on simplification, minus e to the power of t into e to the power of minus t plus e to the power of minus t, this tends to 0. So this becomes minus 1. So now I will multiply minus e to the power of t inside here. When I multiply inside, minus e to the power of t into e to the power of minus t plus into minus e to the power of t into e to the power of minus t minus into minus plus e to the power of t. Now here look at it, t minus t as it is, e to the power of t into e to the power of minus t becomes e to the power of 0. So e to the power of 0 minus this also e to the power of 0 plus e to the power of t. Now minus t into e to the power of 0 is, e to the power of 0 is 1. So this becomes minus t minus 1 and plus e to the power of t will be my solution. So now this is what f of t star g of t. Now I need to find Laplace transform of f of t star g of t is equal to, now apply Laplace transform of minus t minus Laplace transform of 1 plus Laplace transform of e to the power of t. So now this becomes Laplace transform of minus t becomes minus 1 by s square to the power of 1 minus Laplace transform of 1 becomes 1 by s plus 1 by s minus 1 will be my Laplace transform e to the power of t. So now this becomes, I will consider LCM. When I consider LCM, s square into s minus 1 will be my LCM. So now, change the numerator, so according to LCM, this becomes minus of s minus 1 minus s into s minus 1 plus s square. Get that? So now, here on simplification, minus s, minus into minus plus 1 and minus s square, minus into minus plus s square divided by s square into s minus 1. Now minus s plus plus will get cancelled, minus s square plus x square will get cancelled. Finally I will be getting 1 by s square divided by s minus 1. So this finally I will be getting as 1 divided by s square into s minus 1. So I will keep it as equation number 2. So this is now from equation 1 and 2, what are we getting here? From equation 1 and 2, my convolution theorem is satisfied. That is Laplace transform of f of t into Laplace transform of g of t equal to Laplace transform of convolution of f of t and g of t.